Imagine looking at the horizon and seeing a solid wall of red dirt a mile high. It moves fast enough to swallow an entire city in minutes, completely blotting out the sun. In Arabic, the word for this is haboob, meaning blasting or drifting. When you see footage of one rolling over a highway, your brain almost rejects it because it looks like a special effect from a disaster movie. How does a perfectly calm, quiet afternoon in the desert spontaneously transform into a 7,000-foot tall tsunami of sand? To figure that out, we actually need to stop looking up at the sky and look down. The atmospheric forces driving this giant wave are remarkably similar to what happens when you turn on a backyard garden hose. It all comes down to what happens when a thunderstorm finally begins and water splatters outward perfectly. Up in the sky, swap the water for falling cold air and the surface for the desert floor. Slamming down, the cold air splashes outward, bulldozing millions of tons of dry silt. The towering wall of dust isn't the storm itself. It's the massive splash of loose earth pushed for miles in front of a dying cloud. If we look at a real storm with X-ray vision, we can see the mechanics at work. The towering dust is simply the visible leading edge driven forward by a wedge of invisible cold air pushing from behind. This also explains why human choices matter. When we clear flat land for agriculture and till fields during a drought, we leave vast stretches of loose topsoil exposed, supplying the wind with extra ammunition. Nature, however, has built-in ways to break that momentum. Physical barriers can catch the wind and act as a giant filter. Take the Ara Valley mountain range in India. The lush, steep hills create a barrier. The terrain forces the wind to pass through the trees, which scrub the sand from the air and drain the storm of its power. A Habu scale is entirely dependent on having an unbroken flat supply of loose earth to fuel its outward splash. This relationship between the wind and the soil isn't limited to our own atmosphere. When we observe global dust storms swallowing the surface of Mars, we are watching the same mechanics in action. Searing temperature differences are pushing heavy air across a dry landscape. Whether it's in the Sahara or on a world millions of miles away, the same rush of air across a dry landscape creates the same familiar wall of dust. The next time you see a wall of dust rolling toward a city, you'll know exactly what's happening. You're simply witnessing a thunderstorm's giant dusty exhale.